A guy named Aristotle said, that's crazy. I like earth, air, fire, and water. Go from what's called the billiard ball model to something called plum pudding, to the nuclear model, to the solar system model, which is what I just kind of talked about, and we'll talk about in more detail. And then the cloud, electron cloud model, which I've already mentioned. And that's the one that's currently most common for scientists. The one most taught in school is the solar system model, which is probably what you will teach your students. So, see where these things come from. As you may or may not know, hopefully you do know, light is made up of all the colors in the rainbow. Roy G. Biff. Red, orange, yellow, green, blue, indigo, if that's a real color, and violet. I guess they needed a vowel. I can't talk today. It was Isaac Newton who came up with this idea that white light is made up of all the colors of the rainbow already in it. That turned out to be very controversial in his day. He said most of the people did not believe, most other scientists in England refused to believe that white light already had color in it. Otherwise you would see them. But and the reason he knew that this must be the case was he would take light from, say, a window, shine it into a room through a prism, and the rainbow of colors came out against the wall. And then he said, well, now if I take one of those, say the violet one, and run that through another prism, so he physically blocks all the colors except through a little pinhole, he allows just violet light to get through and not the red light. And you go through a second prism, you don't get any new colors. You get no change. And that led him to conclude that light is made up of the colors already, and that there's nothing, you don't divide the colors into smaller pieces, into other colors. Most of his colleagues would not believe that, but it turns out he was true. It turns out that Isaac Newton said that light was a particle. Because it could reflect, just like a billiard ball reflecting off of something. Just like a ball bouncing off the floor, that's a reflection. And because light can reflect in a mirror, he said it had to be made of particles. He wanted it to be made of particles. Nature of science here. He wanted it to be some particular way. Why did he want light to be a particle? Possibly, but he had laws of motion of particles, and he wanted light to obey that. He couldn't prove that it did, but that's what he wanted, so he said they're particles, not waves. Everybody else said they were waves, like a water wave. And you probably think of light in the form of light waves, not particles. Turns out light can reflect, it can also bend, it can also do other wave sorts of things, which we'll get into in our optics toward the end of the term. The only particle part was the reflection part. So by the 1800s, it was becoming believed that light, in fact, was a wave. And I'm not going to go through all of this too much just yet. A man named Michael Faraday thought that light was a very special thing called an electromagnetic wave. Visible light turns out to be a wave. It's called an electromagnetic wave. It means that it's like if you have a electrical charge, you can make magnetism from it. And if you have magnetic fields, you can make an electrical field from it. They go back and forth. Michael Faraday learned that light was probably some kind of electromagnetic field interaction. And it only happens at the speed of light. And it turns out there's an entire range of electromagnetic waves. And you're walking around in a bunch of them right now. There's radio, infrared, meaning less than red, then the visible, which we see, red, orange, yellow, green, blue, violet, Roy G. Biv. Then ultraviolet, meaning beyond violet, X-ray, and gamma ray. For most of human history, we've only known about this little piece. Only in the 20th century did we learn about the rest of this stuff. So we've known about some of this stuff less than 100 years, or right at 100